Welcome back to the Automation Podcast, the world's number one industrial automation product and technology show, thanks to you, our audience of highly skilled automation professionals. Thank you for being a member of our audience, and thank you for tuning back in this week. Now, for those new to the show, my name is Shawn of Insights in Automation, and each week I invite a new vendor on the show to tell us about their products and technologies. And during their presentation, I play the role of the audience, asking questions I think you may have and questions I have as well. And given that a quarter of our audience doesn't watch but listens to the show, I also try to call attention to any details in the visuals that I think the listen only audience may want to know about. So, with that said, I want to welcome Alex to the show. Alex, it's great to have you on. This is a product we covered in the news last week or the week before. We've been keeping up on the daily news of all the new products you guys have been coming out with and the awesome blogs you do. But before we jump into the K50Z Multipoint Sensor, could you tell us a little bit about yourself?
Thanks a lot, Shawn. My name's Alex Novak. For everybody on the show, I'm a product manager here at Banner Engineering, and I'm with the sensors business unit. So I support a lot of our products, but our newest one we brought to market is the K50Z. So I'm excited to talk about it today. So starting off, K50Z, it's probably unlike anything that you've seen before, but it's a 3D sensor. So a multi-point sensor with many measurement points in one device. And the goal of it is to provide efficient measurement, useful measurement, viewing across a wide area with the potential of saving money, time, commissioning effort by using less hardware and making efficient use of the two different outputs that the sensor provides. So two totally independently configured outputs that do not rely on one another to function. As you can see from the picture in the center of the screen, for those that are listening, it's an 8x8 grid and a multi-pixel imager that receives back a lot of data, and then our sensor actually crunches all that data down into some useful measurements that I'm sure we'll get into as we discuss it further here. Any questions you have right off the bat, Shawn?
No, I just think it's amazing that you can choose any zone in that 8x8 area to look at, how far away different things are. Very cool.
Yeah, and that area is quite large. Being able to select zones is definitely one of the key features, but also the fact that it's 45 by 45 degrees coming out of the sensor face out to 2 meters. So you end up with about a 1.6 meter by 1.6 meter cross-sectional area at the furthest distance. So you have a really, really wide view depending on what your targets may be. So in some cases, we've seen the sensor used in filling scenarios where the user wants to monitor the entire contents of a bin, or cart placement where a cart might not be positioned in the same area every single time, or placement of an object where if you're using a single laser or a single ultrasonic sensor, perhaps that detection would be missed. The measurement points as well, the 64 points. So getting into the grid a little bit before I show too much in the presentation, how the sensor works is it emits an infrared laser out from the face in that large beam angle, and then it waits for a reading back on each individual pixel on an 8x8 imaging component. Each one of those pixels has an associated distance measurement and an amplitude measurement. And the sensor takes those and internalizes them and produces outputs that you as a user, whether it's controls or operations or retrofitting a process or speccing out a new process, can determine where you want the sensor to look. So while we have these 64 points, we provide back useful simplified measurements, and we don't necessarily need to use all 64, but we have the ability to use them. And lastly, with it being time of flight, it's very resilient to things like an angle of a target. So you won't have signal bounce away off into nothingness as a certain item is presented to the sensor, placed in front of the sensor, like you would have with an ultrasonic. And the pixel density that we have is very reliable in seeing items that would otherwise be difficult to detect. So like a pallet with the slats and air gaps between the wood pieces, we have a much better reliability of detection of that, or a mesh cart that has air holes or air gaps between the cross hatching. We have a very reliable detection on targets like that by covering the large area with so many different measuring points. I mean, it's three really key bullet points that cover this wide area. We'll get into configuration a little bit next, but I always like to stop and make sure that, if there's any other questions, or if you think something that the audience would be interested in knowing more about this specific section, we can definitely do that.
On the news, we covered a couple of applications which I thought were really cool, and I'll just throw them out there. We covered the bin, so we know that some, raw materials, when they go into a bin, they don't naturally just all settle on one side or the other, and it can be dependent. It can just be how the first few pieces fell. If they're parts, they can bulk up in different areas, and so this could be a great way to say, hey, we're gonna, we have two outputs, left and right, or front and back, and if they're not both the same distance, we could say, hey, we got an unbalanced load. We need an operator to go over there and kind of, balance the load there, so we don't spill over on one side of the bin, but on the other side it's empty. And the other one was, like you could monitor actually two different bins, right? So if you had two package bins, you would know if both of them were full. You could use this in place of two different sensors. So those were two of the applications I remembered from the product announcement. Do you have anything to add to that?
Yeah, and actually, they're really well-timed questions, because it actually segues into this next slide that I
Oh,
have.
perfect.
And so when you take into consideration that wide area, there's a lot of data that we can access and then tell the sensor to process it one way or another. The fact that we have two outputs and air, we're able to decouple them and have them sense different areas or measure different things is really, really powerful. And it sounds exciting when you first hear it, but when you watch it go into an application like you just described, it becomes apparent how much value and how powerful such a small, straightforward, compact sensor can be. So what this image is showing on the screen, it's a 3D representation of the sensor and just a basic representation of the field of view, and it's partitioned into a left side and a right side, a red side and a blue side. And it shows that really what we could tell the sensor to do is focus on a left or a right side. And mind goes to what applications could that be? Well, like you said, if I had a bin or I had a filling application, and at the fill location, you get mounding or something, whether it's boxes or other materials, or parts or metal shavings, whatever it may be, they'll accumulate faster in one zone than they will in the bulk of the bin. Being able to monitor those two areas independently, both the fill area where it accumulates faster, as well as the entire area to monitor a true fill level, and we do that through an average height measurement, is useful because it gives you the information of the area is full or not, as well as maybe action needs to be taken to shake a container, or an operator needs to stop by, or some other action needs to happen so that the fill operation can continue to happen uninterrupted. So yeah, very powerful. And that configuration isn't limited to just a left and right zone. With the 64 different points present in the sensor, we can selectively go in and turn pixels on or off. And the sensor will understand that, use that, and it's very straightforward and intuitive with the software that's free for download from the Banner website. Really, it's a point and click functionality to set up the different zones. So in the image I have on the screen here, it's two 8x8 grids. Each one represents zone 1 and zone 2. And I'm telling the sensor to look at a blue zone that has a K and a Z in it, and then a red zone that has a 5 and a 0 in it. So the sensor would selectively only use those pixels for each respective output when making its measurements. So not just a left and right or a front and back, but truly a very customizable, user configurable sensor to really fine tune it for what the application may be.
And I think what's interesting about that one is the fact that you can have the same pixel in both zones, because the KZ and the 50, they kind of overlap.
They do. Yep. They again, they're totally independent of one another, so that doesn't mean that they have to be exclusive to pixels. You could have them use the same data. So you could honestly overlap the two zones completely and measure an average height and a nearest, or an average
Oh, all
distance and a
right.
nearest distance. So you could get two pieces of information from the same measurement area, and that's just a different application of the two outputs.
Excellent.
The other application you referenced is monitoring two areas, and in the context you said it was two filling containers, but really, if we looked at just coarse detection or measurement of two different zones using those two outputs on the screen here for those listening, I've got another picture of the sensor representing the field of view, and then two lasers that were looking in the target areas and just doing basic detection of an object that's placed on a table. And the sensor could basically replicate what those two lasers are doing for detection and replace them. So now you're left with one cord set that's running from your PLC to the sensor, instead of the two that you'd need for the other sensors. And that's only if you need two different detection zones. If you have something like an array of 8 sensors that spans an area and it's just trying to detect when something passes underneath, we could set up a strip of maybe 2 pixels by 8 pixels, and we would be replacing more sensors than just two. So we're not limited to replicating the functionality of only 2 sensors. It's really, are you using multiple single points to try and do detection, whereas now we can configure a wide area and hone in on what that area you're covering with many single points is.
Now that brings up two things for me. Number one, I mean, when you see the lasers like this, you're like, yeah, I got a much bigger area I can monitor. If the parts aren't always exactly in the same place, this
Mhm.
is going to be much easier to monitor. But the second question that comes up is, if I do have a series of these next to each other, do I have to worry about crosstalk? Like, does the laser from one, will that affect the pixels of another?
Yep. So if they're put very close together, you may see crosstalk events, but there's functionality built in to each sensor where you can turn the emitter on or the emitter off, so you can sync them up through the PLC and
Oh, all
avoid
right.
that. Yeah. So there's methods to work around it, but inherently with other optical technologies, crosstalk is a potential. I would say that we have ways to mitigate or eliminate it though.
Okay.
So those are the core presentation slides that I wanted to show, really just highlighting the wide viewing area and the fact that we can customize the sensor so holistically that you can really tailor it to whatever it is that you're inspecting or the area that you're inspecting. And I do have some slides on the software as well, which we can do a live demo of that, and I'll talk through it as best I can for anybody who's just listening versus watching the video of this. But we did develop a software interface just for this sensor. So it's brand new. It's based on a platform that we use with some of our other products, so our radars, um, and our newest released radar, if we haven't talked about that one, also uses that same software package as well, the Q90R and Q90R2. But K50Z has its own environment and look and feel. And like I said earlier on in this uh, discussion, it's very intuitive feedback that we've gotten from all walks of industry, whether it's engineers or operators or test subjects that I had during development or internal people, or have all had the feedback of it's intuitive and easy to use for the amount of data that you're getting back from the sensor. So just some call outs here before I bring on the live demo is we have a 3D area in the center of the screen that we call the observation space. And with a 3D sensor, it's more difficult to conceptualize without visually seeing something like this, what the sensor is actually viewing. So this gives us a good view into how the sensor is seeing what it's pointed at, and makes it much easier to configure the zones for sensing in specific areas. We've got controls interface. And for those people that are out in the field configuring sensors, this was a feature that we added specifically for when you're on the or in the field, on the floor, at a machine, at a sensor, and not at your desk, and you don't have a mouse readily
Ooh,
available.
yeah.
So, because I've been in that situation before, we got a lot of feedback on that. So you can navigate around in that space with buttons versus having to rely on your trackpad to drag and drop and click to rotate that 3D image around. We've got a few different filters for displaying the actual point cloud itself and colorization depending on distance or excess gain that's being received by the sensor. There's different display options for how the measurements are being represented. Bar graphs, if you'd rather look at the measurement in terms of where is my switch point located and where is the measurement actually occurring. And then the 3D or 2D view. So you can either look at the pixel by pixel data as it's coming in, or you can look in the 3D space and see what the sensor's seeing. I suppose I haven't mentioned it yet, but now that we're talking about outputs and switch points and this and that, the sensor is IO-Link enabled. So we provide, with the two outputs, we have two discrete outputs that go alongside those, as well as you're able to pull the measurement data over IO-Link for both discrete output 1 and discrete output 2. So you could either use those as just simple discrete signals, or you can make more informed decisions in the PLC using IO-Link and the actual measured value. Measurement modes, the two modes that the sensor can function in, nearest distance and average distance. And I wanted to make sure that I highlighted these before I pulled up the software itself. And what you're seeing is two side-by-side images of the same thing. And the only difference is what measurement mode the sensor's in. On the left side, you'll see that there's a translucent red plane that's high. And on the right side, you can see there's a translucent red plane that's low. I've called out the target with arrows as well as the floor with arrows. This was just an object I had for testing that I placed underneath the sensor and then made measurements on it. We have this dark red area that we call a switch point plane. And so that's fixed in space. That's the distance away from the sensor that your output would either turn on or off. And then the measurement plane is the translucent red plane, and that moves with the measurement through the 3D area. So in my nearest distance mode, the sensor is tracking the closest thing that it sees. So the pixel that's closest to the sensor face, and we're reporting back the distance from sensor to the nearest pixel or nearest target. In average distance, the sensor takes all of the data that's being brought in and then averages out the measurement, which is why our measurement plane is now in between the highest and the lowest pixels, or the nearest and the farthest away pixels. That's the preface, we'll say, to getting into the actual software itself, which I'll go to next. Any comments here, Shawn? Anything you think we should highlight for the audience, or anything that maybe you have a question on?
No, I think that slide does and you did a really good job explaining those those are two different modes, nearest and average.
Great. So nearest would be for just basic detection. Average, think of like you could use it for fill or for accumulation, any sort of application like that. So let's go to the software. And what we have here is a live sensor that's right next to me right now. It's just looking at the floor. And I'm just going to slowly rotate it around with my mouse. And you can see that we show the entire field of view that the sensor can see, as well as the measurements that are actively being made. You can see the 64 different measurement points that are coming back from the floor, as well as my switch point plane that's up in the top field of view from the sensor. So it represents quite well visually. And again, the buttons here, it may sound silly to call such attention to buttons, but if you've been out in the field with a sensor that is easier to configure with a mouse and you're trying to use a trackpad, having something like this is incredibly useful, especially having a reset view where you can go to a home position in case you ever get lost in 3D space. So I'll just kind of walk through some of the really, I'd say, exciting features, the unique features, and something that makes it easy to configure, starting with, let's say, these visualization options up in the top right-hand side of the screen. So I have a discrete output, a switch point plane, and measurement plane, and I have red for discrete 1 and blue for discrete 2, so I can selectively turn on and off a switch point. I can turn on and off my measurement plane. I can view an axis, so I can see where my X, Y, and Z coordinate system is. And then I can turn on and off the field of view if I'm not interested in having that gray background. The bar graphs themselves align with the sensor. So if I just position it right next to the bar graph, you'll see it measures from the 20 millimeter dead zone, so a very short dead zone, out to 2 meters. And then I can actually change my switch point just by dragging and dropping the switch point on the bar graph. So that'll actively change where my output would change or turn on or off if I were to introduce a target like my hand coming into the field of view. So visualization, we allow a lot of flexibility for that. Several different response speeds. So you could fast, medium, or slow, as well as the option to reduce the resolution of the sensor itself. So instead of 8x8, I can force it down to a 4x4, and I pick up a lot of response speed by doing that. So an interesting feature as well if you need to operate faster than what some other 3D sensors may be able to do. So I'll go back to 8x8 because it's got the best visualization, the most information coming back.
Now, how are you connected to it? Are you connected via Ethernet? Or are you connected via USB?
I am connected via a USB communication device. We call it our ProKit cable. It's a cable that you would use to configure our radars, our smart lights, our Pulse Pro PFM controlled lighting products, and a few other items from our brand that have configurability. So it's a configuration element that's available on our website. But you could also do some basic configuration through IO-Link. The most configuration you're going to have is through the software interface here. Okay. Let's go into some of the more exciting things. Obviously, we've got some standard features that are present in most sensors, right? Sensor polarity, sensor lockout. This is unique to a 3D sensor where I can actually control the pitch, roll, and yaw and account for angular mounting. So if I'm offset by 10 degrees in a certain direction, or I have to mount to the side of a target area, I can actually have the sensor automatically adjust for those angles that it's mounted at and interpret the data as if it were straight above it. So interesting.
That's very interesting.
Feature set there. The best showcase, I think, of this functionality from the sensor is getting into what we call the active sensing area. And what I'm going to start with is the 2D ROI. So this is that pixel by pixel ability to cut out certain things. As you can see here, I've got an 8x8 grid of red pixels. I can go in and turn off certain pixels one by one or in groups. And in this kind of interesting orientation, now I'm measuring 3 stripes, one thick in the middle, and I can turn off those outer stripes, and now I'm only measuring a thin stripe down the center of the sensor and ignoring the data around it. So with that, if I were focusing on a bin, let's say, or on top of a table, and I had this large area that I wanted to cover, but this field of view is a bit too large, I can only turn on the middle portion of the pixels, and now I'm inspecting just this middle 4x4 section instead of the entire 8x8 field of view. And it's I guess a good way to show it is bringing all the data back. And as you watch, I'm going to bring my hand back into the screen. You should see some pixels show up right here. And my measurement plane doesn't change at all until I cross into that area where I have active pixels actually sensing. So that's one way to constrain the data. If you had perhaps a pole or a beam or something that you needed to ignore as well, you can selectively cut out specific areas to ignore. So it gives you really, really, really good configurability to avoid some of those problems you might find out in an industrial environment and you're, like I said, retrofitting into a processor when you're speccing out a new process, it gives you flexibility in how you're going to implement and mount the sensor. The other way that we have to configure that 3D sensing area is with a 3D ROI instead of a 2D ROI. And now what I can do is you can see I have a large box on the screen here. I can either drag and drop or type in actual measurements directly and then trim out an area of inspection just by telling the sensor an X, Y, and Z coordinate system. So now I'm expecting basically a shoot directly from the sensor face down to the max distance.
Now,
So this, go ahead.
I'm just gonna ask this question. So now, can I tell it to ignore anything that gets very close to it?
Yep.
Like you did the left and right sides, can I do the top and bottom? Like, let's say there's something that goes between the sensor, some kind of, I don't know, some kind of chain that, occasionally goes by the front of the sensor, and I want to ignore that because that's just like a blade of a fan or something. I can tell it not to give any results on that?
Yep, you can. And so what I did
Oh,
here is, you see, we started at 0,
yep.
and as I slowly bring that value down, now anything above, just about 0.5 meters, the sensor will ignore. So I'm going to wave my hand in front of it. You'll probably see the measurement disappear
Hmm.
because
Yes. Oh,
now there's
good.
nothing happening.
But
And
it's
really
not, yeah,
what's happening is you can see my hand is up here being detected, but it's not including those in the measurement because they fall outside my 3D area.
that's awesome.
Is that a common thing you've seen before, trying to ignore fan
N-
blades or?
No, I can see that being a trouble. I can see that being a like a pain point, like, if it would only do this.
Yeah,
So
sure. Yeah, we have total flexibility to ignore targets too far away or too close to the sensor.
nice.
Yep. And then, after you configure one zone the way you want it, we have a completely second zone or a complete second zone that can be configured similar or in a similar fashion to the first one, but you could set it up in a different way. So rather than, having a shoot down the center of the screen, maybe I have my zone 2 looking on the left side of the field of view for whatever reason.
Yeah,
Point
yeah,
is,
yeah.
I have flexibility to control where I'm looking with each independent output. And then I can receive a measurement back directly over IO link, whether it's the average height or the nearest, or excuse me, average distance or nearest distance, whatever I tell the sensor that I want to measure in.
For those people watching, I got to say that the software, just being able to see this like in live and see things coming in front of it and actually seeing your zones and everything, it just makes the software so intuitive and easy to know that you're setting it up the way you wanted to set it up. Versus if you could just add all these in and maybe you had like a scratch pad and you were trying to keep track of it, it's not the same as seeing it live. And I can see this would be great to kind of validate your settings when you start running production. You can say, okay, let's see if I set it up correctly. Maybe I forgot something. Maybe, I need to go deeper or wider, So, no, that's great. I love how it's just this live streaming update of all 64 pixels. Um, if you have it set up for that many, but no, that's awesome.
Yeah, yeah, and really the goal of the software and the goal of the sensor is to really provide this access to 3D information and
Mhm.
3D data in a easy to consume, intuitive way, and really trying to lower the barrier of entry to getting that kind of data out of a sensor. So I don't know if we typically talk about prices on this podcast or not, but the list price of the unit is $545, which
Wow.
for access to this kind of um, data and this configurability, where I can set up all the configuration parameters of a 3D device in a handful of settings on one screen. I think it's a great value to a lot of users.
Yeah, I have to agree with you. That is a great price.
So one last view that I'll show here is a 2D view versus a 3D view. So if you wanted to inspect this very specific
Yeah.
pixel, and I'll wave my hand one more time, and you can watch it start to cross the field of view. This helps for troubleshooting or for configuration as well. If we'll say that that's a beam blocking my field of view, and now I can pick which pixels I'd want to ignore out of that very selectively. So I'm
Yeah.
got a good guide to follow now of which one or which ones I should ignore and which ones I should bring into the measurement.
Well, in a lot of applications where there's not going to be a lot of height to your measuring, where it's going to be more pattern recognition, or that stuff is in the right place, I can see that 2D being much easier to kind of see than the 3D.
Yeah. Yep.
And it's just simpler on the eyes too, but I still like the 3D. Nice.
Yeah. It is like I said, try to provide straightforward, intuitive feedback to make configuration as simple as possible while still giving access to this data, and then having the outputs just be pre-processed. So we don't need any sort of um, controller as an accessory to this. We don't need any sort of external lighting. Everything that's ever needed to run this sensor is on board this sensor. You set it up for the application, you let it go, and it'll provide you the data that you've configured it for, without any sort of other instruments touching it, besides connections to the PLC and power, of course. Um, yeah, it's the applications that we've seen have been immense. It seems like the versatility that it provides allows it to succeed in many applications where they've historically either been difficult or have been um, a long list of sensors needed to service one particular area. Um, I mean, Shawn, have you seen that in your career? When a user is trying to measure a certain area and the best solution, whenever that time may have been, was several sensors all tied together, inspecting different um, locations around for, whatever the target may be. I've got some in mind, but I'm curious what you've seen from your
Yeah, no,
experience.
and then those types of applications kind of become a nuisance to program. So, it's like not only is it, I got to have all these sensors, that gets expensive, and what if one fails? But then the programming side, well, it can be kind of like it can be a little mind teaser for the brain, but a lot of times they turn into tedium because, you don't have this visual view. So you're trying to imagine it and you're trying to program it, and then things happen, you can't see what's happening. And you end up in many cases building a data log or a data logging it somewhere else, so you can say, how did this thing get through my beams, all my different sensors? And I've seen people do that with light curtains where they try to use it to do something like this. Where it's not a safety light curtain, but each beam gives you a difference. And this just seems like it really makes a lot of applications easier just out of the box. But I'd
Mhm.
love to hear what the audience thinks. Guys, let us know what you think. Send us your comments. You guys know how to get in contact with us. We get the feedback link, the talkback links on the website, but and you can also comment on the show. But in any case, what were you thinking of, Alex?
We had this great test where, as a pallet is being wrapped with clear packaging
Hmm.
film, there's generally some sort of mechanical element that spins around and applies the wrapping to the palletized items. And that arm would go up or down depending on, where it's already placed or needs to place wrapping. And uh, typically, or I guess in our experience, we found that several lasers were used to always detect that the pallet was present, that that
Hmm.
it was always there. And as the arm moves, different angles are introduced to what the lasers are seeing, which necessitated the need for several because they were all mounted at different angles, so detection would never be lost on the bulk of the items. And then as more of the plastic is applied, more and more, or I guess different reflectivity becomes a question. So having the lasers, having several, ensures that detection was never missed. If a single laser was there, there's a chance that it shot off into nothing as
Hmm.
the arm wrapped around. So using the K50Z in place of several lasers, as it was wrapping around the palletized items, we never lost detection. And really, I guess I'll just do it on the screen here. All we used was this 2D ROI that I'm playing with on the screen at the moment, and setting a band across the field of view. So there were several lasers, and all we did was replicate that banded area that the application needed to see, and had this detect when the arm was too high wrapping around the pallet. So it should continue to go back down and continue wrapping. So replacing several lasers with a horizontal K50Z doing detection on a pallet as it would wrap around.
Nice.
Yeah. So it's we've seen so many different applications with that sort of need where it's been solved a certain way, but it might not be the most optimal way. And we have a great opportunity here to provide um, the users, the audience, with perhaps a method of simplifying either current installations or new installations with the flexibility of measurement.
Yeah, this is definitely one of those things. This unit and the programming cable, because the software's free, is definitely something I think a lot of engineers are just going to want to have in their drawer. They're going to be like, there's so many different places I can use this in the plant. I'm just going to keep one in my desk drawer so that when a new application comes out, I can just run out there with it. And I know people who do that with color sensors and other sensors too. To start working on the application, prove it out, do my proof of concept before I place the order. And yeah, I would love to hear from the audience if you guys actually go out and get one of these and what you use it on, because I'm stuck in the office these days, so I don't get to see what you guys are doing.
Yeah. Yeah, it's pretty amazing some of the applications that we find. Um, are there any other, I guess, questions you had that came up, Shawn, or discussion points, or anywhere else that you think we should dive in a little bit more for perhaps people that are listening, or something I should
No,
expand upon?
no, I think we covered it all. I think probably the best bet would be to end on, where they find out more information.
Yeah. So we always have lots and lots of information on our website. So www.bannerengineering.com. And this will be, I mean, the links to this product will be here and there scattered out because it is a new item for us. So you'll probably see some of it on LinkedIn. You'll probably see some of it on other social media channels, as well as advertised on certain portions of our website. But it's fairly easy to find. You search K50Z, it'll bring you to this page, and we've got all the supporting files that you might need for understanding if a demo unit or a test unit is what you need, or if you want to just understand more about how the sensor works. So all the specifications that are associated with it, we've got AOI files, we've got IODD files, the manual, all sorts of supporting documentation to um, help support users out in the field, because it is intuitive, but it's always nice to have material readily available if any questions do arise. Otherwise, we're all friendly here too. If there's questions, and I'm sure there's somebody in your area, um, depending on where you're located, to help assist if you do have any comments, questions, or would like to talk about getting a unit for testing in a certain application. Um, lots of points of contact.
Yeah, and two, you guys probably noticed there's no commercials in this episode. That's because Banner sponsored it, so it's commercial free. So you'll also find the top 5 links in the description, the show notes of this episode. And we thank Banner for sponsoring it to allow us to go through and make it ad free, so the audience, don't have to listen to any ads. And I'm noticing on the website too, there's all kinds of contact us, chat with us, talk to an engineer. So there's multiple ways to find out more about this product as well. Before we end this show, Alex, was there anything else we want to cover?
No, I think we really hit all the main topics that I had prepared, and I think we've had some good conversation about them. Really, it's I'm just excited to showcase the product itself in a manner that I don't think the automation industry necessarily gets enough of. I mean, it's nice to be able to talk about such a new product in this sort of manner. And I hope that there's users out there listening who think that they'll find value in it, with how much area we can cover with a single sensor, and providing that 3D information back to you without charging an arm and a leg for it.
Yeah, pretty awesome. Well, I want to thank you for taking time out of your busy schedule to come on the show and talk to us about this awesome product we saw in the news and we wanted to learn more about, and really appreciate it, Alex. Thank you for your time.
Yeah, thank you, Shawn.
Well, I hope you enjoyed that episode, and I want to thank Alex for taking time out of his busy schedule to come on the show and tell us all about the K50Z, including giving us a short little demo. I really appreciated that. And I want to thank Banner, too, for sponsoring this episode, making it completely ad-free. I know you guys love that, and it helps me underwrite my costs to produce the episode, which I really appreciate. With that said, if you did enjoy this episode, please remember to give us a like, a sub, and a share, because that is the fuel that keeps us on the air and coming back week after week. And as always, if you want to get in touch with me or you want to reach out to me, you can do so over at theautomationblog.com. And you can also find all of my automation training courses over at theautomationschool.com. With that, I want to wish you all a very healthy and happy week. And until next time, my friends, peace.